Hey guys, Mr. Bowman here. Today's learning objective, following on from our one on prime numbers, is in white, and we are learning to determine the prime factors using a factor tree. So that word prime has come up again, and we are extending our understanding of prime numbers by trying to figure out what the prime factors of a given number is. Let's have a look at a bit of an example. So the other thing that we need to know is about this idea of a factor tree. What is a factor tree and how do we use it? So let's have a look at the number 6, an easy example to start off with. We need to think what two numbers are going to multiply together to get that 6. And we're going to split that number into its two parts. And that there would be 3 and 2. We then need to think, can we split 3 and 2 up? And the trick is, if they are prime numbers, we are going to stop. But if they are numbers that are not prime numbers, we're going to keep carrying on with our splits. And in our case, 3 and 2 are both prime numbers. And that means 3 times 2, they are the prime factors of 6. So that was an easy example to get us going. Let's look into a slightly different example, and we'll slowly escalate this in difficulty. So the next one I want to look at is number 18. So we've got to think, what two numbers multiply together to get 18? And some of us may have thought 6 and 3. But I'm also going to do it again here as well, just to demonstrate something. Some of us also may have said 9 and 2. And once we've done our first split, so we're going to look at 18 over here. If we identify a prime number, we want to circle it because we're going to stop there. And if we identify a number that isn't a prime number, for example, that's 6, we're going to carry on and split up again. So we're now going to think, what two numbers multiply together to get 6? Well, we did that in our green example, and that becomes 2 and 3. And we've got to think, do we split them or do we circle them? These are both prime numbers again, so we're going to circle them. So that means the prime factors of this would have been 3, which is the first circle, times 2, which is the second circle, times 3, which is the third circle. And if you do the maths, 3 times 2 is 6, times 3 again gets us to 18. And we're going to carry on again with our second version of 18. So 2 is a prime number, so we're going to circle that. And we've got to think about number 9. Is it a prime number? Is it a not? In this case, it's not, because I know that 3 times 3 becomes 9. And we've got to think about the 3s. 3s are prime numbers, so we're going to circle both of those. And everything is circled, so there's nothing else to split. And we've got to write our factors down. So that's 3, which is the first circle, times 3, which is the second circle, times 2. And the thing I wanted to note is, we can have a look. We've got 3, 3, and a 2. And here, we've also got 3, 3, and a 2. So the split that you decide early on, that won't impact your answer. You will, no matter what you choose, you will get to the same answer. And finally, let's wrap our work up with a bigger example, a harder number. Let's choose the yellow pen. I've chosen 240 to split. So we need to think, what two numbers are going to multiply together to get 240, and it could be any of the numbers. You could pick any things, and I'm going to pick 60, and I'm going to pick 4. 60 times 4, that gets us to 240. And now we've got to think, are either of them prime numbers? Well, I know 60 times divided by 2 is 30, so that's not a prime number. And I know 2 times 2 is 4, so that's not a prime number either. So let's split these again. We can pick any split you want. So I'm going to pick 3 and 20, because I know 3 times 20 is 60. You might have picked 2 times 30. You might have picked 4 times 15, 6 times 10. You could have picked any of those. And the 2, or the 4, that's going to be 2 times 2. So now that we're at this layer, we've got to think, are any of these prime numbers? And a lot of them actually are. So that 3, that's a prime number. So we'll circle that. That 2, that's a prime number. And that 3, that's also a prime number. So all of those are prime numbers. But that does leave us with 20. We've got to keep splitting up that 20. So can you think what two numbers multiply together to get 20? Well, I'm thinking 2 and 10. That's a nice easy one to do. So let's do 2 times 10. And well, we know 2 is a prime number, so we can circle that. Now we've got that 10. Well, 2 and 5 come to 10, so we need to split that up. So let's do 2 times 5. 2 is a prime number, and 5, that's a prime number too. And we've circled everything. Everything comes to a circle or an end. That means we can now form our prime factors using our factor tree. So we're going to just follow our thing. So we're going to go 3, which is that one, times 2, which is that one, times 2, which is that one, times 5, times 2, times 2. And that would be our factor tree. And just a note, these could be in different orders. The order of it doesn't matter. As long as you've got 4 2s, a 3, and a 5, your answer would be correct. Hopefully you found this video on factor trees and prime factors useful. Let's get into some questions now.